So we had finished sound, right? Completed. So we did numericals in that. Two numericals we did, or two numericals are balance?
No, we did.
So you want me to do the remaining, or will you do it yourself? Because, so you can try it yourself. You'll do it, right? It was simple, just one formula. V is equal to 2D by T. Okay, so shall I start with chapter 8, which is current electricity?
Yes. So, I didn't complete this chapter.
Did we discuss the characteristics of sound, like loudness?
The last thing we did is equal depth sounding. So, we have not completed the chapter.
So there is. So you have to tell me that. Huh?
Yeah, we didn't do resonance. We didn't do the.
Were you present in the last class?
Yes, sir. We did.
No, resonance नहीं. ये जो quality में you have characteristics of sound, loudness, pitch and quality. Did you do that?
No.
तो वो करना है, ठीक है? Yeah. Good. You reminded. So, okay, let's do. But resonance and all we have done.
Resonance.
So characteristic. ठीक है, we'll finish the characteristic, and if there is time, then we'll take up the balance.
So we didn't do resonance.
We didn't do resonance.
We did sonar and radar. That is sound receiving.
We did resonance. I had written resonance over here, I remember. Huh?
Yes, sir, we did.
We did resonance. See the comparison. Did you write the 4 columns?
Yes. Frequency of object should be
Equal to, yes, exactly. We did that. After 1 week, even I don't know. Did I tell you that the waves look like this for free vibration, damped vibration? We have done all this, right?
Yes.
We have done all this. You were not present in the last class, maybe.
No, sir.
Force vibration.
Have you brought a different notebook?
Yes, I was not present.
That's what I'm saying.
Yes, on Saturday I was absent.
Saturday?
Yes, sir, it was on Saturday. I was absent on Saturday. Extra class we had.
We had an extra class for this? That's what I'm saying. So, yeah, I was just about to go back. Like, anyway, I'm struggling with my memories. And now you tell I was not here. So. Okay, so we did till resonance. Part B we have completed. Now part C, right? Characteristics of sound. So first of all, what is the meaning of this, right? So how do we differentiate between different types of sound? For that we need some differentiating factors such as, so we can differentiate different sounds on the basis of following characteristics. So there is a lot of portion which is not for exam, okay? So whatever I teach you, only that, right? So we can differentiate different sounds on the basis of following characteristics. So what is the first one? Loudness. Loudness of sound, right? The second one is pitch. And third is quality. Right? So what is loudness? Loudness of sound, it depends on amplitude. So we'll discuss one by one on the right side. So loudness of sound depends on amplitude. Amplitude. Right? So let's draw the graph. So let us say we have a sound which the graph looks like this. Okay. What is the amplitude here? This is plus A and this is minus A. Okay. So if this is the base sound, the loud sound will be something like this. Okay. So what is the difference between the two graphs? So this is 0. Is the frequency changed? No. Why? The cycle completion, that is the time period of both the graph is same. If the time period is same, the frequency is 1 by t, same. Has the nature changed? The waveform changed? No, it is similar. So what has changed? Only the amplitude. I am saying Ujjwal, right? Now I am saying Ujjwal. So you make out that both time I am only speaking, right? So has the source changed? Right? So frequency has not changed. The energy, which depends on amplitude, right? It's like energy, speed. So the sound is same, but now it is more strong, right? What? Okay. So loudness depends on amplitude. So when you really displace the particles to a longer amplitude, so it will show the loudness, right? But then there are some deep people around, right? Deep, deep or deaf? What do you say? Deaf. Okay. Tell me. Deaf and not so dumb. Okay, not so dumb. But deaf, right? So to a deaf person, you speak slow or you speak loud doesn't make any difference because the sensitivity of his ears is gone. Like it's not sensitive, right? So loudness is a therefore subjective what do you say characteristics. Loudness is a subjective characteristic. Meaning a loud sound may not be loud for some. Like if there are some rock music fans, so they really love loud sound. They play to a very high volume, and then the mother comes She's trying to convey some message to you. You're in your own world, and then suddenly stick falls on your head, right? So what happened? Okay, so I'm yelling, and you're not saying what yelling? That's what it is. Okay. So loudness may not be really loud. It depends on the sensitivity of the ears, right? So then, what is objective? So objective quantity is intensity. Loudness depends on amplitude, and what is the objective characteristic? Objective characteristic is intensity. Objective means it can be measured and written as a number, right? So what is intensity of sound? Intensity is given as energy flowing per unit area per unit time. The energy upon time is power. Okay, so it is power flowing per unit cross-sectional area. Right? So if somebody is speaking, right? Let's say I'm speaking here. So I'm like sending rarefaction and compression.
Udays कौन है?
Red t-shirt.
Who signed the attendance sheet?
Yeah, he came just now.
You came just now, I think.
For this class he came.
You
Maths
came,
me were not there.
Because I directly came from the class.
Okay, that is sign. तो sign करो.
wait, the attendance sheet was not here. No? I didn't bring the attendance sheet.
And that office work out ना भी
Is
चलेगा.
it?
Yeah.
So rest of you signed the attendance sheet?
Anyone missing?
No, there are people signed in the first class for the second class as well.
Yes. Anyone missing? कोई बाकी नहीं ना? आ रहा हो आप जब? नहीं है ना? Sign करो. ठीक sign करो.
All of you have signed?
अभी वो लेके आया था ऑफिस को. चलो आप लोग खुद भी याद रखो कि साइन किया है कि नहीं किया, okay? Sorry sir.
It's okay. So if I am speaking, right? So in the medium, how is the sound traveling? This way, right? So how is the traveling? How is the sound traveling? So if this is the plane in which the sound is progressing, right? So this is the area through which the sound energy is traveling. So sound energy traveling per unit area per unit time. That is intensity. Okay. So it's, what is the unit of intensity? Joule per second per meter square. Okay. And joule per second is watt. So you can also have the intensity unit as watt per meter square. So this is a unit of, so this is an objective characteristic of sound. Okay, just write it down. How do you pronounce leaf? Not left. How do you pronounce this? You got my pain? This is what bothers me all the time. This is what bothers me. What's the rule, man? I mean, what's the rule? See, which is advanced? The phonetically pronounced sound is the same as you write. So this is much advanced. and it is being appreciated by NASA now. So this is the we call this lipi as Devanagari lipi, right? Okay, and the base is Sanskrit. The Germans, the US guys, they are reading Sanskrit. They are offering PhDs in Sanskrit now. Our own Indians are getting doctorates from there. And we have very minimal work happening in Sanskrit in India today. But now it's changing. Okay, so we'll change all that. French scolded all this Englishmen long ago, but it's English because of America. So English is no more owned by UK, right? It's American English, which is an international language now. So it doesn't belong to UK. The present form of English is an international form of English. So we're managing right now with English as the linked language, but it has many weaknesses. And the computer is not human. You cannot tell computer भी जब PUT आएगा तो put बोलना, जब CUT आएगा तो cut बोलना. ऐसा you can't tell computer. Humans you can tell. डंडा मार के ऐसे बोल. But for computer you have to have a logic. So that logic works better in this. Therefore they are working on that. Okay. Anyway, now you get it. Why I was saying deep? Because maybe my teacher, when he was teaching me, he said deep. So I became deep. Is it done? Right side?
Yes.
Now let's understand pitch. What is pitch of sound? Pitch of sound depends on frequency. Okay, so in the earlier case we said amplitude, right? So intensity depends on amplitude. So amplitude is like the quantity, the what do you call the objective thing, right? Intensity depends on amplitude, square of amplitude. So therefore, amplitude was the objective thing there, as was intensity, right? Now, what is pitch of sound? It depends on the frequency, right? So, how do I explain this? So first, let us draw the graph. So this will help you understand what is the difference. So our base sound is this is our base sound. Somebody is chatting. right? So as the amplitude change here. So now if I say Ujjwal, okay. So how do I? So let's say Ujjwal was this sound. How will be this sound? How would Ujjwal sound when I speak with this frequency? Huh? Yes. किसने बोला? Correct. So Ujjwal बोलते बोलते कभी क्या हो जाता है गले में फंस गया अरे Ujjwal बोला तो the sound energy is not increased ठीक है फंस गया ये ज़्यादा vibrate हो गया okay let's say Ujjwal was like my vocal cord was like doing like this Ujjwal ऐसा हो जाता got it so that's how it is so the male voice is generally flat so male voice has low frequency so M-A-L-E, right? Male voice has low frequency. So it's called flat sound. Right? So the male vocal cord vibrates at a smaller frequency, therefore the sound has more bass. Right? Okay, you must have seen on music system bass or bass. It's called bass. Bass. B-A-S-S. Bass and treble. Right? What about female sound? Shrill. So you accept. So female voice is has high frequency. So it's called. So it sounds both shrill. Okay. So I always take name of Mamata Banerjee when she speaks, right? So it's like but with Lata and Asha Singh, it looks very soothing, right? I mean, it's very soothing to hear. But there are some it's better not to go further. So female voice is like in the fish market. Right? In the fish market, if some lady is like quarreling, not talking, quarreling, then that's you can't stand it for a long time. So it's also shrill. So they have high treble. Terrible, what terrible? They wanted to say terrible, but they gave a technical term called is it treble? What is it? Yes, treble. T-R-E-B-L-E. So treble, right? So in musical instrument, which is more bass and which is more treble?
Harmonium is more treble.
harmonium, string, right? String based musical, but the
Piano.
not piano,
Drum.
drums. It's called a specific name it has.
Manjirans also have treble bass.
Treble. No, bass is like tabla has a bass, the thick one. It has a high bass, but the thin one has tan in Japan. Dab is bass, tan is treble. Okay, so that's what it is. Those drum instrument percussion. It's called percussion. Okay, all the percussion is all this. They have more bass, like the drums. Bass. Okay. Is it understood? Now, what is objective and what is subjective in this? Objective is of course frequency. The cycle can be counted, right? And pitch is subjective quantity. Like again, it depends on the sensitivity of the listener. Okay. So, what could be shriller to some for a very sensitive listening capable person? It may not be like any sound to somebody whose sensitivity is low. Okay. But frequency is something which can be expressed very. Is that clear? So that's this is objective. And this is subjective. Next is quality. What if there are sounds? There are two sounds whose amplitude and frequency are same. Then how will you make out the difference in them? Let's say you are speaking at the same level at which she is speaking. Without looking at you, I can make out that both persons are different. They are speaking with the same frequency and at the same energy level. So I am able to identify you, right? How?
The quality.
That is quality.
Like
Okay.
for the work.
So the waveform will have same amplitude, same frequency also, but there will be difference in the waveforms. Here both waveforms are similar, right? But now the waveform will be different. So quality. Quality actually depends on the waveforms. Right? So let us say one of the sound has how did you get about that frequency thing? Did I do that earlier?
No, in Einstein.
Huh?
In Einstein, it was
It was the same topic was there, right? Okay. So now if you read the book, you should understand it. There are so many things like we are not going to cover that. Let's say this. Okay, so are the waveforms different now? Is the frequency different? No, the cycle is repeating itself after same time. So is the amplitude different? No, right? Same level. So energy same, frequency same, but still. So let's say this is the sound coming out from flute. This could be coming out from say guitar or something. Okay, so the musical instrument are different or violin, right? That So even without looking at the source, you can identify that it is produced by two different sources. So that is differentiated with the subjective quality called quality of sound. So this is a subjective quality. Right? What is objective is yes. So anything which can be experimentally measured is objective or quantized. Quantized means quantity, number can be attached to it. Then we can differentiate easily. Okay. So for analyzing, you need objective data. Okay. And rest is hearing and sensation based. So sensation based is subjective data. Got it? Okay, so this completes our discussion on characteristics of sound. So then many students have asked me to explain what is given here, right? Let's look at the description. The quality of musical sound depends on the number of subsidiary notes and their relative amplitudes present along with the principal note. So what is principal note and subsidiary note, right? So there could be a musical instrument which is branded and unbranded, right? So when you play that instrument, the unbranded one may be like very mediocre sound, right? But a branded instrument, very well made, the sound will be more richer and it will have more variety. Okay? So which one would you go for? You'll prefer a branded, right? So what is the difference? So difference is, see, suppose you have a musical instrument, right? Right. So in some instrument, all the frequencies are possible. They are played to be possible at all frequencies, right? All frequency by mean there is one principal frequency, right? And the all other frequencies are multiple of those frequencies. Okay. So let us say this is a string guitar. So if this is the length, right? So depending upon where you have plugged it. So if you plug it in the middle, only this one loop will be formed, right? If you plug in the middle, so this one loop will be formed, right? But in terms of wavelength, how big is this? Lambda by 2, right? So what is the velocity with which it is traveling? So velocity is equal to f lambda, frequency times lambda. So therefore, what is the frequency? V by lambda, right? Now, what is L? L is equal to lambda by 2, therefore, lambda is equal to 2L, correct? This is V by 2L. So this is our principal frequency for this musical instrument. Now, if I pluck it, say at 1/4 of the length, instead of middle, instead of half, I pluck it at 1/4. Then, wherever I pluck, there will be maximum amplitude, and this is how it will travel on the same length. So we are getting 2 cycles now. The frequency has doubled, right? So when the musical instrument is tied at both the ends, right? Then what is this frequency? The F1 was this. Now let's calculate how much is this. Now in this case we are getting a different lambda, right? So we are now calling it. So in this case it was lambda 1. We are now calling it lambda 2. The wavelength has changed, right? Here the wavelength is like this case, but here now wavelength has reduced, right? Now this is a metal string, so the medium has not changed, so the speed of sound will be same in this medium also, right? Medium is same, so but the frequency has changed now because of the way you have played the instrument. So what is the frequency now? F2 will be equal to V by lambda 2. What do you get? V by, but lambda 2 is equal to L. So lambda 2 is L. So I can manipulate this. I can write it as 2 by V by 2L. But what is V by 2L? It is F1. So this is 2 times F1. So F2 is the subsidiary frequency and F1 is the principal frequency. The sounds are different. But so when the frequency changes, the sound changes, we have seen, right? So I can play it with that much more variety. If I, let's say, have the third frequency, when I further hit it at 1/6, so now I will have 3 loops. Right? I have, got it. Same length, I am keeping the same length, only I am playing it at different, plucking it at different lengths. Right? So now what do I have? So this will now return. So now how many, what is the wavelength now? Now it will be a different wavelength. Wavelength is reducing every time. So this is lambda by 2 plus lambda by 2 plus lambda by 2, 3 lambda by 2. But lambda is now, I am calling lambda 3. I am giving it a name. Right? 3 lambda by 2. So now lambda 3 is equal to 2 by 3L. So this gives lambda 3. Right? What is the relation? L is equal to 3 lambda 3 by 2. Therefore lambda 3 is 2 by 3 L. Right? So what is the frequency now? So therefore F3 must be V by lambda 3, which is equal to 2L. Now 3 comes in the middle. This is now 3 times F1 only. So all the subsidiary frequencies are multiples of principal frequency. Got it? So if you buy a musical instrument which has more and more subsidiary frequencies possible, that is that much more versatile instrument. Got it? This is what it meant. So I gave you an example using string device. It's applicable for flute also. So if you take a flute, okay? So if you take a flute, right? So there are 2 types of flutes available. One which is closed at one end and the other which is open at both the ends. Okay? So these are called harmonics, different harmonics. Fundamental note and harmonics or overtones. So when the flute is open at both ends, it has got all the harmonics present. Like here you have odd and you have even. Right? Then odd and then even. All harmonics are present in this case. String instrument tied at both ends. In this case also, just like this, all harmonics, both odd and even, are present. And both ends are open. Both odd and even frequencies are present. But here, only odd are present, evens are not present. In this case, so it has limited range. This is much more versatile. You got it? Only odd frequencies are present. Odd frequencies are present. Right. So when you take the ratio here, right? So F1, F2, F3 in this case will be in the ratio 1:2:3. Whereas in this case, F1, F2, F3 will be in the ratio 1:3:5. Here it will be F1, F2, F3 will be present in the ratio 1:2:3. Right? So for the first frequency, the fundamental frequency is present, but the second frequency is 3 times that. So the 2 times is the same. So less versatile. Got it? Okay. So when you are reading this chapter, you might come across this description. So this is what it means. Now read this. This one, just below the quality wale description. Yeah. Thus, the quality of a musical sound depends on the number of subsidiary notes. So F2, F3, F4, F5, they are subsidiary notes. Notes means frequency, notes. Okay? Note indicate different sound. So quality of a musical sound depends on the number of subsidiary notes and their relative amplitudes present along with the principle. Right? And all that we have discussed, right, has been summarized in this table. Okay? So the characteristic loudness, pitch, quality is also known as timbre, right? So, timbre. So it depends on quality depends on the waveform, pitch depends on frequency, and loudness depends on amplitude. Okay, that is how that. So is this understood by all of you? Right? Here they have given you another example. This waveform, but now it is different. Now this must be noise because this is not regular. Can you see this? If the waveform is regular, it sounds better to you. But here it is irregular. So it's a random sound. So that will appear to you as a noise. So only difference between music and noise is, so the hearing sensation is pleasant in case of music. Noise is irritating, right? It's unpleasant. That's it. Then we have measuring sound. So what is the unit in which the sound level is measured? It is measured in decibel. There are so many other formulas expressed in terms of logarithm and decibel. Don't bother about it. Okay? Don't bother. So it's not going to come. What you have to understand is, even the decibel definition they will not ask you. Just familiarize yourself with this table. Okay? So any sound which is more than 120 decibel will qualify as a noise. Even police siren is a noise only, but then they are saying greater than 120. So these sounds in small duration won't hurt you, but a persistent hearing of sound of a higher decibel level will may hurt our eardrums. But then those are temporary only. It becomes better with time. So what is the minimum sound dropping the pin? So is a pin drop silence, right? Have you heard your English teacher often mentioning, children, pin drop silence? Okay. So this is pin drop silence. Then the leaves rusting, right? Okay. Recording studio, your friend, soft whisper. So the girls and the boys who whisper, right? That's 30 decibel. So now this is 30 decibel. Okay. Normal conversation is 50. So this is 50. This is okay. Pleasant. Vacuum cleaner, little loud. Huh? Then motorcycle or car, 80. And auto rickshaws, much more than that. Huh? Really irritating. Then you have diesel lorry, 90. Heavy hammering machine, like. Do you have any construction work going on in your area? I come from Koppur here, I live in the station area. There's this huge construction going on, and the terrain is totally rocky. 8 hours they're breaking rocks. It's like they're hammering on our head. So I'm facing 110 decibel 8 hours if I'm in the house. Okay. Okay. Pop concert 130 and it's pleasant, huh? Right? I love rock and pop, so it's pleasant for me. But not for long hours. And an aeroplane takeoff is 140 decibels, so you have to avoid such sound for a long duration. Alright, so with this we are done with the sounds chapter, the theory part. We have 10 minutes still, so let me take one or two minutes. Give me a volume. You have a volume? You have a volume? चलो कौन सा एग्जाम कौन सा सम किया था आपने पेज नंबर 126 so UT volume page number 126 okay a man standing 48 meter away from the wall fires a gun. So anybody has any question? Here this is the big lecture actually. Go through the video, okay, because it has a lot of concepts. So, okay, question 3. UT volume, page number 126. Question number 3, right? Classwork. Classwork evaluation. Yes, any confusion? Now I will read the question. So, a man standing 48 meter away, right, fires a gun. Now calculate the time after which an echo is heard. Right, speed of sound in air is 320 meter per second. So the firing of bullet takes place here, right? And it goes to the reflector and comes back. So this is 48 meters and again 48 meters back, right? Goes this way and comes this way. So where is the gun? Okay, so 48 meters goes and comes back. So you have to find the time. T is equal to what? Given V is equal to 320 meter per second. Okay, so how much is this? So since what is the speed? 2 times distance, 2d upon t. Okay, so t will be, therefore t is equal to 2d upon 2 into 48 upon 320. That many seconds. So 4 ones are 4, 4 to the 8. Right? So this is 4 3s are 12, 20. 0.6 second.
So 0.3.
Huh?
That one is also there.
0.3, correct. This 2 will also get cut, no? So this is 2, this is 10, correct. Okay, so straight question. Question number 4. Shall I erase this side? Have you noted it down? No? This is a very important discussion actually. But it will not be asked. When you now read your book, will you be able to understand what is written over here? Will you be able to recall or watch the video? Okay? Okay? So ये लिखने की जरूरत नहीं है. The principal note and subsidiary, it's only about that. Because these calculations are in 12th standard, not now. But it is mentioned in Icse. So in ICSE they have really loaded on the syllabus. So many advanced concepts they teach in lower grades. Okay, question number 4. So pendulum has a frequency of 5 vibrations per second. So given that is equal to 5 Hz. An observer starts the pendulum and fires a gun simultaneously. Okay. He hears an echo from a clip after 8 vibration. So time of echo. T is equal to 8 vibrations. So what is time of 8 vibration? So time period here is, time for one vibration is 1 by 5. So for 8 vibration it will be 8 by 5, right? 5, correct? So therefore time period is equal to 1 by 5 seconds. What is time period? Time for one vibration. He says he hears the echo after 8 vibration. 8 into 1 by 5 is 8 by 5 seconds. Correct? So now what you have to do? If the velocity of sound is 340, V is equal to 340 meter per second. Right. What is the distance between the clip and the observer? So D is D equal to what? Right? So what is the formula? D is equal to
2D by T.
Dt by 2 now in this case. Yeah? Correct? So same formula, since D is asked, substitute 340 into 8 by 5, that's V into T and that's divided by 2. Okay. So 2170. This is 17 into 10 by 5 is 2 into 8. How much is this? 17 into 16. Find out how much is this. How much is 17 into 16? 272. Is this correct? Wonderful. We have more time, so let's do one more. So are you getting the numericals are not difficult. Just one formula you have to get it right. Question 5. Man fires a gun and hears its echo after 5 seconds. So time of echo is equal to 5 seconds. A man then moves 310 meters towards the hill. Okay? And then fires the gun again. So let's say this is E. And then he travels 310 meters. So this will be E minus 310. Okay. So time here T1 is equal to 5 seconds. Here T2 is equal to 6 seconds. Right. So then what you have to find out? Calculate the speed of sound, right? Now the speed of sound is same in both the cases. So this is T1 and T2 is equal to 3 seconds. This is the situation. So now V is equal to 2D upon T1, right? V must be equal to 2D upon T1. We have to find the speed, right? And V is equal to 2 times T minus 310 divided by T2. Okay. So from here, what is D? So this is equal to 2 upon 5. This gives us D is equal to 5B. D is equal to 5 by 2B, right? So now substitute. This is 1. Substitute it over. So you substitute it over here. So what do you get? So therefore B is equal to 2 by T2 is how much? 3 seconds. And D is 5B divided by 2 minus 310. Okay. So D from equation 1, I just substituted over here. Just rearrange, substituted for T. What is this? This is 5 by 3B minus 2 into 310 divided by 3. Okay. So it's rearranged. So you have what do you have? 6. Okay, I take 3 over here. Cross multiply 3 over here. So 3, right? So it is therefore 6 2 0 is equal to 5B minus 3. So this is 2, right? It's 20. Therefore, what is B? 620 by 2. 310. Is this the answer?
Yes.
So see, you have to basically analyze the given situation. Right? So for full distance, it is taking 5 seconds, the echo time. When the observer moves 310 meters towards the reflector, this is the sound effect. Then the distance is reduced by 310. So this is it. Okay, so now sound chapter is finally complete. So the next class, this is whose volume is this class? Okay, I'll see you in the next class.
Thank you, sir.
Thank you.
Yeah,